x of t equals 1 by 2 pi j times, so integration x of t e power st dt. This is what we have. So if I go with this, what I'll do is I'll just exchange these t and interchange this t and tau. So what I'll do is replace t with tau at first step, so that what will happen, I'll get x of tau here, right? And this will be 1 by 2 pi j times, this will be, of course, what is this, what did I write? X of s. So this will be what? X of s times e power s tau t tau, right? So everything will change because we've interchanged t and tau. Now what I'll do here is I'll integrate both sides, right? Both the sides from minus infinity to t, right? So I'll take integration inside this because only t is valid here. So this will be from minus infinity to tau, right? So this is what we have done, isn't it? Gurtunda idi?
Yes, sir.
Any reply from EC?
Yes, sir.
Right. So this is one way of doing it. So while doing this, I have clearly said you that there is an other method, because once asked in question paper long back, I don't know, malli anta complex adutado letteridu. So this is how we have done. So we can do the same procedure here. But the question is asked like this. Understand this point clearly. The question is asked like this. Prove integration in time using the convolution of f of t and u of t, right? So ee renditi convolution use chesi ee property ni prove cheyamannadu, right? This is very complex and immediate ga thought raadu, but try to understand this point. Now let me take this expression. Anta ayipinaka meeku clarity vastundi, but as of now just blank simple mind toti ee proof vinandi. So f of t into u of t, let me take. So how do we write this? Minus infinity to plus infinity, right? F of tau u of t minus tau d tau. This is the expression for convolution, right? Isn't it? Now understand this each and every point carefully. Now let me try and find this u of t minus tau. So for this, what should I do? Let me take this u of t first. Clear? Or u of tau. Let me directly go with u of tau first. Then let me do u of minus tau. So what this will be? This flipping your x-axis. So this becomes u of minus tau. Then let me go with u of t minus tau. Right? So if I have it here, so then this will be your u of t minus tau. Right? So this will be what? T. Now, E point clear kada, ikkada clear kada, because we have done many problems on this, operations on signals. I have to find this u of t minus tau. So for that, I have taken u of tau, then u of minus tau, right? Then u of t minus tau, or this can be written as what? If I take u as common, అంటే మీరు ఏ ప్రొసీజర్ 3-4 ప్రొసీజర్ చెప్పాను మీకు నేను, బట్ మీరు ఏ ప్రొసీజర్లు చేశారో తెలియదు, వేరే అంటే a few other guys it seems, right? So this will be what? This can be written as minus tau plus t, right? So ఇలా చేస్తే ఒక విధంగా వస్తుంది, ఇలా చేస్తే ఒక విధంగా వస్తుంది, but end of the day this will be your answer, right? Minus tau ki plus t అంటే advance, right? So it వస్తుంది. So this will be from minus infinity to t, right? So signal ఎక్కడి నుంచి ఎక్కడికి ఉంది ఇది? Minus infinity to t. Is that clear? Yes. ఇక్కడ దాకా క్లియరా?
Yes, sir.
Yes, sir.
Right. So now let us go back to this expression. F of t convolution with u of t will give you what? Minus infinity to plus infinity of course f తీసుకున్నాం కదా, so f of tau, right, u of t minus tau d tau. Should I now go with minus infinity to infinity? Because ఇది ఎక్కడి నుంచి ఎక్కడికి ఉంది సిగ్నల్? This is from minus infinity to t, isn't it? So should I integrate this now from minus infinity to plus infinity? No, because this signal, ఈ సిగ్నల్ ఏదైతే ఉందో, this is non-zero value. ఎక్కడి నుంచి ఎక్కడికి ఉంది? మైనస్ ఇన్ఫినిటీ నుంచి టీ వరకే ఉంది, రైట్? ఇక్కడ నుంచి ఈ పార్ట్ అంతా దిస్ ఇస్ జీరో. సో ఇంటిగ్రేట్ చేసి కూడా వేస్ట్. సో ఎక్కడి నుంచి ఎక్కడికి ఇంటిగ్రేట్ చేయాలి? ఐ షుడ్ నాట్ డూ ఇట్ ఫ్రమ్ minus infinity to plus infinity. Now this is not infinity anymore. This will be from minus infinity to t. Is this clear now? Is this point clear?
Yes, sir.
Right? So now what I'll do is I'll change this integration values. This will be from minus infinity to t. Because this is valid only non-zero value. ఎక్కడి నుంచి ఎక్కడికి ఉంది మనకి? మైనస్ ఇన్ఫినిటీ నుంచి టీ వరకు మాత్రమే ఉంది. ఆ తర్వాత అంతా ఈ వాల్యూ ఎంత? జీరో. దీంతో ఎంత మల్టిప్లై చేసినా కూడా ఆన్సర్ విల్ బి జీరో. సో దెర్ ఇస్ నో నీడ్ టు ఇంటిగ్రేట్ ఇట్ ఫ్రమ్ minus infinity to plus infinity. I should integrate it only from minus infinity to t. Clear? So now understand this point. I'll have f of tau, right, u of t minus tau d tau. Clear? Now what is the value of this from minus infinity to t? u of t వాల్యూ ఎంతమ్మా? ఎక్కడి నుంచి ఎక్కడికి తీసుకున్నా కూడా, దాన్ని ఎటు తిప్పినా కూడా వాల్యూ ఎంత? u of t 1. So even from minus infinity to t, the value is 1. So can I write this minus infinity to t f of tau d tau? Is this fine? Okay, Nara?
Yes, sir.
Because this is equal to 1. So I need some response. Right? So please kindly respond. So this is equal to 1. So what I'll do is I'll just write it as, so I'll write this as f of t u of t. Now this is equal to this. Now let me call this as equation 2. Find the 1 this kunna. So let me take this as 1. Right. So ikkade malli rapthe me confusion undadu, right? So what is the property now? Let us go to property, right? So let me take this as 1 and let me go to property. What is property? Property is saying x of tau, minus infinity to t, x of tau d tau. Whether it is x of tau or f of tau, whatever it is, this is same, right? So this must be x of s by s. Now equation 1 and the left hand side of this, both are same or not? Whether it is x of tau or f of tau, whatever it is. Understood?
Yes, sir.
So this part, equation 1 and the left hand side of this property, both are same, isn't it? So instead of proving this property like this, equation 2 ni ila as is ga prove cheyadam kante, this is equal to what? Integral of this. So what I'll do is f of t integral u of t, దీన్ని లాప్లాస్ అప్లై చేస్తే x of s by s వస్తుందని ప్రూవ్ చేస్తా. Now both are same, isn't it? Now both are same, isn't it?
Yes, sir.
అర్థమైందరా? So this is what the question is. అంటే ఇంత టఫ్ అడగకపోవచ్చు, బట్ కర్మగాలి ప్రాబ్లం పడితే ఎందుకు బేసిక్ ఎలక్ట్రానిక్స్ తో మళ్ళీ మనం రిస్క్ తీసుకున్నాము. సో let us try to touch each and everything. Okay, so f of tau convolution with u of tau should be equal to x of s by s. నేను ఇలా ప్రూవ్ చేస్తాను because these two are same and this is equal to this. So if I can prove this is equal to this, after convolution, after Laplace transform, then I can equate this equal to this. Right? So this is how the idea goes. This is how it will be, because this is the question asked to prove this using integration in time, right? Our property ni ila prove cheyamani adigadu. సో ఇప్పుడు నేను కన్వల్యూషన్ తీసుకుంటున్నాను. నౌ కమ్స్ ది యాక్చువల్ పిక్చర్. ఐఎమ్ టేకింగ్ కన్వల్యూషన్ నౌ. సో లాప్లాస్ ట్రాన్స్ఫార్మ్ ఇక్కడ సింపుల్ అవుతుంది. లాప్లాస్ ట్రాన్స్ఫార్మ్ ఆఫ్, బికాస్ ఆల్రెడీ మనము ఇలాంటి ప్రాపర్టీ కూడా ప్రూవ్ చేసాం. ఇదేంటి? దిస్ విల్ బి ఎఫ్ ఆఫ్ ఎస్ ఇంటూ capital U of S. Capital U of S. Right? Or X of S. Let me go with like X of S itself. Mali confusion in the Miku. Let me write this as X of S. X and I, F and I, that's just a output. Right? So X of S into U of S. Is this fine now? Yes. Which property did I use here? Convolution in time. I've used convolution in time property. Right? If it is convolution here, it will be multiplication in frequency. All right. So now, what is this X of S? What is this U of S? Right? U of S and NT. What is this U of S? What is U of T? Step signal. What is U of S? Laplace transform of step signal. Clear? Laplace transform of step signal. So what is the Laplace transform of step signal? What is the Laplace transform of step signal? We have proved it already. What is this? 1 by? Yes. Right? The Laplace transform of step signal is 1 by S. If you prove kaakapoyina mee cheyakapoyinte, no doubt this is a standard signal. Step signal is a standard signal. The Laplace transform that is 1 by S. Right? So if I substitute this in this, so Laplace transform of X of T convolution with U of T. Right? If it is convolution in time, multiplication in frequency, X of S into U of S. Right? So I'll just write this X of U of S as 1 by S. Right? The Laplace transform of step signal is 1 by S times X of S. Right? So what is this equals to? Laplace transform of X of T convolution U of T. But what is this convolution equal to? What is this convolution equal to? We have proved it here. What is this equal to? This convolution equal to this one, minus infinity to T X of tau D tau. So in place of this convolution, what I'll write here is Laplace transform of minus infinity to tau X of tau D tau equal to what? 1 by S times X of S. Right? If I have to remove this LT, this becomes to tau T in fact T. So X of tau D tau, applying Laplace will give you 1 by S into X of S. That's all. Now have you understood this?
Yes, sir.
So the question is this. Actual property is this, minus infinity to T X of tau D tau should give 1 by S times X of S. This is the property. Right? Which property is this? Integration in time property. Right? So, but what we have done is, instead of proving this, first we have proved that minus infinity to T X of tau D tau is equal to X of T integration with, convolution with U of T. We have proved it. Right? By using this graphical method or taking those, we have proved this. Right? So now, instead of proving this, if I can prove X of T convolution with U of T is giving you 1 by S times X of S, then this is equal to what? This one. So I can, in place of that, I can write minus infinity to T X of tau D tau. Now this is giving you what again? 1 by S into X of S. This is what I have done. This is what the question asked. right? So దాన్ని ఇట్లా అడిగాడు, డైరెక్ట్ గా ఈ క్వశ్చన్ అడిగాడు. దిస్ ఇస్ వాట్ హీ ఆస్క్డ్. ఆ ప్రాపర్టీని కొంచెం జస్ట్ రీరైట్ చేసి అడిగాడు, ప్రూవ్ దిస్ అనేసి. సో దిస్ ఇస్ హౌ యూ కెన్ ప్రూవ్, రైట్? I'll just repeat it, just go through this complete derivation. Now this is the property, this is the property, this is the ROC. So as I said, we have to go like this, right? So I have to go with x of t, replace t with tau, take integration on both sides. So this we have done in which transform is this Fourier transform lo ee process cheskuntu vellam manam, right? So but appudu aa roju cheppanu meeku there is another method to do. So this is what the method is, convolution, right? Using the convolution. So దీనికో ఏం చేశాను నేను, I have taken two signals, x of t అయినా f of t అయినా same, don't confuse. In place of f capital X వస్తుంది, right? In Laplace చేసినప్పుడు. Okay, so now what I have taken the convolution of these two, right? So then ఈ ఒక్క టర్మ్ ని తీసుకుని నేను I have started drawing this, right? Which term is that? I have started drawing this u of t minus tau. So దానికోసం ఫస్ట్ నేను u of tau తీసుకున్నాను. జనరల్ గా u of tau అంటే ఇలా ఉంటుంది with 1, right? దాన్ని ఫ్లిప్ చేశాను, this is u of minus tau, alright? So దీన్ని ఏం చేశాను, మైనస్ ఇన్ఫినిటీ టు t తీసుకున్నాను. అంటే I have just drawn the u of t minus tau, right? ఎలా ఉంటుంది, ఇలా ఉంది, ఇలా ఉన్నది కాస్త ఏమవుతుంది, కొద్దిగా అడ్వాన్స్ గా స్టార్ట్ అవుతుంది. This will be t minus tau, right? So now it is no more from minus infinity to 0. కొంచెం ఇంకా కొంచెం ఎర్లీగా ఉంది. సో అంటే ఏంటి, మైనస్ ఇన్ఫినిటీ టు t వరకే సిగ్నల్ ఉంది. We don't know what is the t. జనరల్ గా కొంచెం t can be 2, 3, whatever the value is, right? If the value is mentioned, it will be in place of t, it will be 3, 2, whatever the value mentioned there, right? So based on the value it changes. So now we have generalized it and taken as t here. So this will be from minus infinity to t. Other than that, it will be a 0. We'll have this non-zero value only from minus infinity to t. Okay, so we need not integrate this. Ippudu din integrate minus infinity to plus infinity cheyalsina avasaram ledhu, because this signal is existing only from minus infinity to t. So we have changed the limits change chesanu ikkada nenu, right? So this is from minus infinity to t. Okay, so what is this u of t minus tau? Value is always 1. నువ్వు ఎంత షిఫ్ట్ చేసినా, అడ్వాన్స్ చేసినా, డిలే చేసినా, whatever it is, the amplitude is 1, right? ఎక్కడి నుంచి ఎక్కడికి 1, minus infinity to t, the value is 1. So let me omit that and write this as minus infinity to t f of tau d tau, right? Only this term, because this is 1. Okay, so now what is this equals? The convolution of f of t into u of t, isn't it? So now what I have done here is, instead of proving this, I go with this. Prove, if I can prove this equal to this, right? Then obviously this equal to this, because these two are same. These two are equal. So this is the basic idea. With this, what I have done is, I have taken Laplace transform of x of t convolution with u of t. Now we can use a property called convolution in time property. If it is convolution in time, then it will be multiplication in frequency. So this will be x of s into u of s, right? What is this u of s? U of s is Laplace transform of, so Laplace transform of u of t is equal to 1 by s. If proved, EC lo మనం చేసినట్టు ఇది, and CSC లో ఇంకా కాలేదు ఇది, right? But anyhow, తీసుకోండి, we will prove it, right? So Laplace transform of u of t equals to 1 by s. So if I can apply this, so x of s into u of s is 1 by s. So a one line answer. Properties vartedi, just two lines lo vachesi. Which property we have used? Convolution in time property, right? So this will be 1 by s times x of s. Right, so this is the property. This is how we have proved it. Yeah. So next one, yes, differentiation in frequency. Right. So differentiation. So differentiation in frequency. This is a property, and what the property says is x of t, if giving x of s, if this is true, with ROC equals to R, all right, then t into x of t we generally take, right? T into x of t should give, gurtunda property, t into x of t problem ko solution din meeda, right? T into x of t will give you minus 1 times d by ds of x of s. So can someone tell me what it is in a Fourier transform? And ROC for this will be equals to R. There's no change in ROC. Can someone tell me this in Fourier transform? Quick. Can someone revert back? T into x of t in Fourier transform and inverse Fourier transform will give you what? I need someone to revert back. Quick.
Sir,
Yeah, ma.
J into d x of omega by d omega.
J into d by t
Omega of x of omega.
x of omega, j omega, whatever it is, right? So what is the difference that you can see here? Only difference is in place of j omega you have this. Yes, of course we have minus 1 here, right? So we have to prove this. So let's prove, right? So yes, it should again, what is that you understand? Which one should I take? Should I take Laplace transform or inverse Laplace transform? If it is Laplace transform, starts like this, x of s equals. If it is inverse Laplace transform, starts like this, x of t equals. So which one should I take?
Laplace.
See, I understand this. I need differentiation here. Right? So in kawali term. So what I'll do is I'll go with Laplace transform. So let me go with x of s. So what is x of s equals minus infinity to plus infinity x of t e power minus st so e power minus st so e power minus st dt we have, right? So what we do here is, so we differentiate both the sides with respect to s, d by ds of x of s equals minus infinity to plus infinity x of t, and differential comes here, d by ds of e power minus st dt. This is what we have. Is that fine now? Yes. So what can be done here? So see this part is done. So minus 1 should get multiplied to this. Only the one left is minus 1 should get multiplied to this. So minus 1 now. Okay. So now what happens here is d by ds of x of s equals minus infinity to plus infinity. We have x of t. So minus t times e power minus st dt. The same thing, right? So minus t anedi okati manaki extra undi. So without this minus t, how can I write this as minus infinity to plus infinity x of t e power minus st dt? Just without this will be what? The Fourier transform of, or let me call the inverse Fourier transform of x of inverse Fourier transform of x. Sorry, excuse me. Inverse Fourier transform, right? So the linear rational proof d by ds of x of s equals minus infinity to plus infinity. So minus t x of t, right? So e power minus st dt, right? So then directly etla raychu, simple. If x of t is input, right? If this is input, the expression will be what? Minus infinity to plus infinity x of t e power minus st dt. Is that clear? Now what is the input we have? Input is t into x of t. Is that clear? Right? Now the input is t into x of t, and minus if I take outside, so this will be what? This will be equaling yes. So minus, let me take it to the other side. So minus 1 d by ds of x of s equals what? Let each and every step, don't confuse. So t into x of t e power minus st dt, right? If I have only x of t as input, I'll get x of t here. Now what is the input I'm considering here? T into x of t, right? So what is this? T into x of t. Now is that clear? So how can I write this here? So minus 1 d by ds of x of s equals what? How can I write this as now? How can I write this as, or apply this symbol here by removing that? Let me apply this symbol here. So this will be equals t times x of t, right? So let me write this in the other way. So this will be t into x of t. If I apply Laplace on this, I'll get minus 1 times d by ds of x of s. This is what the proof is. Or I can write this as what? I can write this as Laplace transform, inverse Laplace transform, right? So okay, I can write this as inverse Laplace transform of x of t. So it is the Laplace transform, right? So this is how we can prove. Is that clear?
Yes, sir.
Just look at the screen, you'll understand this. If it is only x of t, this will be x of t here inside this. If the input is t into x of t, this will be t into x of t. Right now, I'm considering t into x of t as input. So this will be what? Inverse Laplace of this. Right. So the next property is integration in frequency. Integration in frequency, right? So what it states is, if x of t is giving x of omega, then x of t by t should give s to infinity x of s ds, and ROC remains unchanged. If this is R here, this will also be R. So what can be done here? What is that you understand? How to do this? Now again, the same concept. I have x of t, I have x of s. Which one should I go with? Which expression should I go with? I have integration for x of s. All right. So I should go with always x of s here. So x of s equals what? Minus infinity to plus infinity x of t e power minus st dt. So if I can integrate this from s to infinity, right? Of course, on both the sides. Now go half part end, almost done here, right? So left hand side, it's done here, right? So if I integrate both sides from s to infinity, so right, left hand side mana ds equals what? I have already integration here, minus infinity to plus infinity x of t, and now let me integrate only s term here. So let me integrate this here. So e power minus st dt. Of course, ds. All right. So now left hand side it's cleared. Left hand side it's done. E part of this in money. Now what we have to get is x of t by t. Right. So for this, what I do here is, let me rewrite this properly. Minus infinity to plus infinity, x of t will be as such. Now I have integration from s to infinity, e power minus st ds, of course, dt here. right? So if I solve this, what is that I'll get? Minus infinity to plus infinity x of t, right? So if I integrate this from, this will be minus st by t, clear? Minus st by t, okay? And of course, yes. So even if I substitute those limits, yes, this is what I end up getting. So this will be dt here, right? So if I take t here, so minus infinity to plus infinity, I'm taking t x of t by t. I'm taking t here, rewriting this e power minus st dt, right? Even after substituting limits, this is what you end up getting, man. Don't confuse, right? So yeah. So this will be what? Now if it is just x of t, right? So what is on the left hand side? So this will be s2 infinity x of s ds. This is already there, right? So what is the formula I have? X of s ki formula enti? X of s equals to minus infinity to plus infinity x of t e power minus st dt. E formula eppudu valid? If the input is x of t. Now let me consider x of t as x of t by t, right? Ila undanuko. Now if this is the input, if this is the actual input, right? So what happens here? This term will become x of t by t. Input x of t edaithe aa place lo adi ravali. Okay? So for that yes, the same thing is applicable here, right? Now e term lo input enti? What is the input here? X of t by t, right? So this is the input. So how can I write this as x of s ds equals what? Laplace inverse or inverse Laplace of x of t, right? ఈ టర్మ్ ఇట్లా రాయొచ్చు కదా నేను, or x of t by t, because input is x of t by t. పైన కూడా అదే చేసాము, బట్ నేను అక్కడ ఆ టర్మ్ రాయలేదు ఇక్కడ, right? So this is also the same thing, right? So ఇక్కడ ఏంటి? t into x of t is input, right? So ఇక్కడ రాయాల్సి వస్తే ఇక్కడ దీన్ని తీసేసి ఇక్కడ రాయొచ్చు దీన్ని. This equals what? Inverse Laplace of t into x of t. If inverse goes to other side, becomes Laplace, right? So ikkada kuda same thing. So what is it here? S2 infinity x of s ds equals what? Inverse Laplace, right? So inverse Laplace of x of t by t, right? So ikkada emana confusion undara? If any confusion, please let me know. If you can't speak, put a message. Anta maatladaniki problem aithe put a message, so that I'll explain things clearly, more clearly. You already అలవాటు ఉంది కదా, మీకు ఐడియా ఉంది కదా, నేను కొంచెం ఫాస్ట్గా వెళ్ళిపోతున్నాను. అర్థమవుతుందా ఇది? షుడ్ ఐ ఏమన్నా అర్థమవుతుందా?
Yes, sir.
Yes, sir.
రైట్. So if I take out that equals and take Laplace to other side, this is what s2 infinity x of s ds similar, just because I'm taking inverse to other side becomes Laplace, right? So this will be what? Sorry, this will be, or let me why all this was direct step basis, so last step, right? So this will be what? X of t by t, right, is giving you what? Is giving you limit s tends to infinity x of s ds. This is what it is giving. Right? Understood now? Is that clear?
Yes.
Right, so now comes the main thing, initial value theorem and final value theorem. Winnera idi meer Laplace lo, because మీరు ఆల్రెడీ లాప్లాస్ చేస్తున్నారు మ్యాథ్స్ లో. అక్కడ ఇనిషియల్ వాల్యూ థీరం, ఫైనల్ వాల్యూ థీరం వచ్చినాయా? విన్నారా వినలేదా?
లేదు సార్.
రైట్. సో దీస్ టూ ఆర్ వెరీ ఇంపార్టెంట్ ప్రాపర్టీస్. ఈ ప్రాపర్టీ ప్రూవ్ చేయమంటారు, లేకపోతే ఇనిషియల్ వాల్యూ theorem. Right? What it states is x of t, if giving x of s and this is true, then x of 0, initial value, or 0 plus, and not exactly 0, very, very, very minor change, a minor increase from 0, right? Then this should give, then this states this equals to limit s tends to infinity s into x of s. This is very important, and ఈ ప్రాపర్టీ ఈసీ వాళ్ళకైతే పోను పోను చాలా సార్లు యూజ్ అవుతుంది కంట్రోల్ సిస్టమ్స్ లో వీటిలో వాటిలో గుర్తుపెట్టుకోండి, రైట్? ఆర్ ఎక్స్ ఆఫ్ 0 తీసుకుంటారు, సమ్ ప్లేసెస్ లో ఎక్స్ ఆఫ్ 0 ప్లస్ తీసుకుంటారు. బోత్ ద సేమ్, డోంట్ కన్ఫ్యూజ్, ఇట్ కెన్ బి 0 0 ప్లస్. ఇనిషియల్ వాల్యూ ఇస్ 0 at 0, or కొంతమంది 0 is not valid కాబట్టి what we do is we generally go with a 0 plus, very minor change, very negligible change. Clear? Right? So this is the property. So to prove this, we have to consider the property of differentiation in time. Right? So differentiation in time. So differentiation in time is d by dt of x of t. Right? Let me go with multiple. Right? So multiple number of differentiations. Then this is equals to what? Sn into x of s, right? So ఇది ఎప్పుడు వ్యాలిడ్ మనకి అంటే, right? So this is not exactly the property, but the actual properties, we have continuation to it. The initial values, we will generally neglect this, right? It should be like s into n minus 1 capital X of 0 minus అంటే దాని ముందుది, okay, minus, right? So this will be s into n minus 2 x1 of 0 minus, right? And this goes on like this. So this goes on like n minus 3, right? So this will be, I have capital X, right? So yeah, small x, I should go with small x. Small x, of course, right? So this will be 2, right? 0 minus, and that will go on, right? So this will go on. This is the actual property we have to consider, but we're not taking the previous values, we're just going with that, right? So this will go on. So now if I substitute n equals to 1, and if that is a single differential, right? So then that will be like, so d by dt of x of t, if that is a single differential, then that'll be equal to, right, Laplace equation line loaded. Then that is equal to, now understand this point, this will be s into x of s, right? The first one, this is the first one, right? So we'll be left with what? Only two terms is now. N equals to 1, yes, these two terms only considered. N equals to 3, I mean the next value, n equals to 2, then consider this also, right? That'll go on based on the order of the differentiation. This will go on if n equals to 1, right? So we have to go with these two terms. So this will be s to the power 0 x of 0 minus. Is that clear? Is that understood? Yes? Is that understood?
Yes, sir.
Yes, sir.
If any confusion, ఇది చూసారా మీరు ఎప్పుడైనా ఈ ఫార్ములా? Have you seen this?
No,
Yes,
sir.
have you seen this? Right, so anyhow, leave it. So as of now, if I go with n equals to 1, the first one and the next one, I mean the previous one, right? So if n equals to 2, have to consider these 3, 1, 2, and 3. If n equals to 4, have to consider these, right? So it'll go on increasing. So if n equals to 1, right? So this is the actual property we have, but we also have to consider the previous one. Is that clear? So, but we don't generally consider, we neglect it, but for this property, we need to consider that. Understood? So now listen to this. Now understand this point. In this, we go with unilateral Fourier transform or Laplace transform, right? So bilateral we call it, or unilateral. If it is unilateral, right, this will be from 0 minus to infinity. Generally we take like 0 to infinity, one-sided, right? But exactly 0 kakunda 0 minus. So practically speaking, we have to go with 0 minus, right? So bilateral, yes, of course, minus infinity to plus infinity. If it is unilateral, we generally, and one-sided, we generally go with 0 to infinity. But actually we have to go with like 0 minus, ante 0 kante koncham less, very negligible less, right? So now the property, now the thing here is, we have to consider a one-sided, not two-sided, right? So we have to go with what? One-sided Laplace transform, unilateral Laplace transform, right? So then kosam property koddiga peddadi, right? With this we will close it, but anyhow listen to this properly, right? So we have to go like this. What is the actual? We have x of s equals to what? Minus infinity to plus infinity, x of t e power minus st dt. So integration values are from minus infinity to plus infinity. But I said we're going with what? Unilateral Laplace transform, right? We generally go with unilateral Laplace transform. Okay. So for this, the integration values, how am I taking this? Now, see this carefully. 0 minus to 0 plus x of t because we have differential here, we go with differentiation. So direct input this is actual input entity d by dt of x of t, right? To understand this, we have to go with which property? Differentiation in time property. So actual input is d by dt of x of t e power minus st dt. This is the formula, general formula. Don't confuse, right? But to understand this, which property are we going with? Differentiation in time property. So we have to, the input is differential of input, right? So e power st dt.
Sir, excuse me, sir. Sir,
Chitra.
sir, 10:30కి EMTL క్లాస్ ఉందని చెప్పినారు సార్. మేడం క్లాస్ జాయిన్ అని చెప్పింది.
Acha, meer boni mari. Easy guys can move.
ఓకే సార్.
Right, so understand this point. So 0 plus, so 0 plus 2.
సార్ ఇంత మటుకు నోట్స్ పంపండి సార్ ఒకసారి.
పంపుతారా. So 0
okay,
plus
sir.
2 infinity. So I have here d by dt of x of t. I'm just splitting this because we have to go like minus infinity to 0 minus to infinity. We don't have to go with 0 to infinity. This is practical, exactly how the derivation will be, right? So but generally we go with like 0 to infinity, right? But correct ga paddhati ga manaki integration value ravali ante this is how we have to go, right? So e power minus st dt. Okay, now understand this, just like a normal integration, right? So this will be what? X of t from 0 minus to 0 plus, right? So the first one, there's no much complexity in that. So I'll have 0 to infinity. I have a d by dt of x of t e power minus st dt. Initial values would consider cheskunte, this is how we have to go, right? So this will be like x of 0 plus minus x of 0 minus, right? Plus what I have is 0 plus to infinity d by dt of x of t e power minus st dt. Clear? Right, so what is that I have on the left hand side? Laplace transform of d by dt of x of t. Right? So d by dt of x of t, Laplace transform equals to what? X of 0 plus minus x of 0 minus. So please concentrate. 0 plus to infinity d by dt of x of t e power minus st dt. Right? So but what is that Laplace transform of this, right? So by taking n equals to 1, what we have got on the left hand side is s into x of s minus s power 0 into x of 0 minus. This is what we have got initially. Chusara mere initially, yes, this one. So this is proved. D by dt of x of t, Laplace transform apply yesterday, right? So now in place of that Laplace transform of d by dt of x of t, this is what I'm getting here, right? So this is equal to what? Now this is equal to x of 0 plus minus x of 0 minus, right? Plus integration 0 plus to infinity d by dt of x of t e power minus st dt. Right? Now apply s tending to infinity on both the sides. Right? So what will I get? I'll get limit s tending to infinity. Right? If I do this, I'll get anyhow. This will be gone, so I'll be left with only s into x of s here on the left hand side. Clear? S into x of s, now which is equal to x of 0 plus, right? So then I have plus 0 to 0 plus 2, in fact. Yes, so it's to infinity d by dt of x of t, right? So ikkada limit apply cheyali, deeniki limit vastundi, right? So limit here will be what? Inside that limit s tending to infinity, ikkada oka chota kada vastundi manaki e to the power minus st dt, right? So what this will be equals to, this part, if limit e power minus infinity, right, will be 0, so this will be as, this part will be 0, because if I substitute s equals to infinity, this part complete second term becomes 0. So this will be limit s tending to infinity s into x of s equal to what? X of 0 plus. This is what the proof is. This is what the proof we have here. Got it? Yes. Now see what